Okay, so we're now into chapter 3. Chapter 2 focused mostly on the different types of factoring. Now we're going to be using that factoring to solve quadratics or solve graphs or being able to graph. All right, that was the goal. Factoring is just a tool used to solve these problems. So let's fill in this chart here. And again, this is all recall, so this is just all old information, but we'll just put it into a nice summary here, okay? So the zeros also called the x-intercepts of the equation f of x equals a brackets x minus r, x minus s, r, and s. And why is that? That's because if you take a value r, okay, r just being any kind of random number, right? Like it's just a number. We call it a variable because it's a number we don't know. But if you substituted r in for this x right here, so what I mean is if you evaluated the function at r, you would get a r minus r, and then the other one would also have to be r minus s. Well, this bracket right here would evaluate to 0, and then a times 0 times r minus s equals 0. And that's the key thing. X-intercepts occur when the function equals 0. So the same would be true if you took this s and you plugged it in for that x and this s right here, you would also get f of x equaling 0, okay? That's why we call x-intercepts zeros. Well, the x-coordinate of the vertex, all right, so recall from unit 1, the x-coordinate of the vertex is the h value, So remember, a vertex has both h and k. Well, it's this value right here. That's the x value of the vertex. And to find it, we can use a formula where we get the average value between our two intercepts. So if we know our two intercepts are r and s, and if we take the average, the halfway distance between those, divided by 2, you would get the value h. You would find the x-coordinate of your vertex. And once we find the x-coordinate of the vertex, we can substitute this value into the equation to determine the k value. The y, which is the y value of the vertex, which is this part right up here. Okay? Because if you have an equation that relates your outputs, your y values to your x values, which are, we have an equation x minus r, x minus s, and if we substitute in our h value here, h for that and h for that, whatever this equals out to be, it will be the k. It will be the k value, the y value of your vertex. And we'll do more problems like that, okay? And if any of this is confusing, we're gonna get through some problems and you'll see it again, okay? But so right now, let's just keep going through the chart. And so the direction of the opening of a parabola is determined by A. And if A is positive, the parabola opens up. If A is negative, the parabola opens down. And when it comes to the y-intercept, calculating the y-intercept, that happens when x has a value of 0. Because if you think about a graph, you'd be finding a point right here on this axis, or anywhere on that axis, and that would have a x-coordinate of 0 and whatever the y is, all right? But the main idea is that you'd be substituting in x equals 0, or in function notation, f evaluated at 0. Okay, and now if we look at standard form, well, the direction of opening in standard form is also given by A, right? This A right here. And just like in factored form, if A is positive, the parabola opens up. If A is negative, the parabola opens down. And the Y value, well, in standard form, actually this is what standard form is good for. The Y value, the Y-intercept, is the value of C. It's just whatever you see on the backside there. So in this case, it's C. And why is that? Well, if you have this function, f of x equals ax squared plus bx, and I'm going to put this in green, plus c, well, the y-intercept is calculated when x is 0, so f evaluated at 0, and that means you'd be substituting in 0 for this x, and you'd be substituting it in for this x right here, and then you'd have that c on the backside. Well, notice that this a times 0 is 0. This b times 0 is 0. And you're just left with your c value. So when you get it, we're given standard form, you can just look at the backside and say, well, right there, that's your y-intercept, whatever number that evaluates to. So again, this is a recap from grade 10 and also some of it being from unit 1. But that's okay if you can't remember it. We're going to do lots of practice, all right? So let's go through example 1 here. Express the following function in factored form. So let's start there. This is given to us in standard form. So in standard form, we have f of x equals negative x squared plus 16. Well, this is where your math survival guide should kick in and be like, oh, I have two terms there. Is this a difference of squares? Well, sorta. What happens if I factor this negative out right here? Well, if I factor that negative out, I'm going to get negative x squared minus 16. Now we have a difference of squares. In a difference of squares, when we factor that, remember, you take the square root of the first term, so we get x, and then you add the square root of the second term, 4, and then x take away 4. And there you go. That is factored form. We used difference of squares to factor that. Again, it is a tool, all right? So now from factored form, using factored form, you are able to determine the zeros. That is why we get things in factored form, all right? So part A says determine the zeros, the equation of the axis symmetry, and the coordinates of the vertex and the y-intercept. So let's start with determining the zeros. Well, remember, the zeros happen when the value of our function, so this is f of x right here, when it equals 0, because you're looking for when it hits the x-intercept. And remember, this is like y, right? So when does y equal 0? Well, it would equal 0 if either this x plus 4 bracket, if I found an x value that would make this bracket evaluate to 0, or if I found an x value that would make this bracket evaluate to 0. So mathematically, how do you do that? Well, you just take this bracket, this x plus 4, and you say, okay, well, what value of x, solve for x, would make it 0? So bring the 4 over to the other side, and you would find that if x was minus 4, well then this whole thing would equal 0. So there is one of your x-intercepts. But you would also get 0 if you found an x value that would turn this bracket into 0. And same process, bring the minus 4 over, and you get x being 4. There is your other x-intercept. Again, solution, x-intercept, all right? 0. And why are these zeros again? That's because this has a coordinate of minus 4, 0, 4, and 0. I know part B is saying for us to graph it, but let's just put those points on the graph right now. Why not? So we found -4 and 0, and we also found 4 and 0 right here. There are your two x-intercepts. Okay, check, done. The equation of the axis of symmetry. Remember, the equation of the axis of symmetry is x equals, all right, it is an equation, so x equals, because it is a horizontal, sorry, not horizontal, vertical dotted line, and that vertical dotted line occurs at the h value, or the x coordinate of your vertex. How do we get that x value of our vertex? Well, it's the halfway point between your zeros. And we'll do it algebraically, but let's look visually. Where do you think the halfway point between this 0 and this 0 is? Well, this is 4 over that direction, and this is 4 over that direction. So the halfway point you would expect to be right here at the origin. Well, let's see if that actually works out to be true. So our formula says, all right, so let's find the axis of symmetry. The axis of symmetry. Well, our formula, let's put it as a nice straight line. There you go. The formula says, well, when x equals h, all right, or it's x equals h, and h is equal to the halfway distance, so halfway dividing it by 2, between your two x-intercepts. So here is our first one, -4, plus your other x-intercept. So in this case, it would be 4. Well, h equals -4 plus 4, that's 0. Divide that by 2, and you get h equaling 0. Or your equation of your axis of symmetry is x equals 0. And that makes sense. We did it over here on the graph, right? That means we have a dotted line like this going through the point at x0. This has an equation, x equals 0. Done. The coordinates of the vertex and the y-intercept. All right, so let's do this part. Coordinates of the vertex. Remember, the vertex has coordinates h and k. Well, we've already found h. We found this to be 0, so we just need to find k. And recall, k is a y value. And as we've talked up above, you find the k value by substituting in the x coordinate of the vertex, or the h value. So I can actually write in this note if you want to add this. This is when the function is evaluated at h. So let's calculate our vertex. The coordinates of the vertex, well, we get that when we evaluate our function f at h value. And so if we have our function which is written as f of x is minus x squared plus 16. Well, if I evaluate this at f of h, right, and h is 0, well, so that means you'd be putting in a 0 here. That's minus 0 squared plus 16. So then f being evaluated at 0 is equal to 16. That means your vertex has coordinates 0, 16. Well, let's plot that on the graph. That would be right here, 0, 16. The last step was finding the y-intercept. Well, we've already kind of done that. The y-intercept is evaluated when the function is evaluated at 0. Well, it just so happens that our h from the previous problem was also at 0, so we've already evaluated the function at 0. So in this case right here, we have a y-intercept at the coordinate 0, 16. So it just happens that our vertex and our y-intercept are the same, meaning that the parabola has its maximum point right here, right up here at the intercept. And now to graph it, it's just connecting the intercepts together. The vertex and the intercepts. So you just connect your intercepts and your vertex. Keep in mind your arrows. There you go. So if this is on a test, what I'm expecting is one, these arrows. So if I see that, check, because the graph is going downwards for infinity. It will never stop. It always goes down. I expect to see this axis of symmetry. Check. I want to see you label this graph. So we graphed f of x. That was the problem. And then I want to see these points if they actually exist. Okay? So you're looking for, I want to see intercepts, vertex, axis of symmetry, and label of the graph. All right, so we get more practice now. Determine the maximum or the minimum value for the following quadratic functions. So the maximum or the minimum value, here we're looking for the k value, okay? The k value is either the max or the min. So if you think about it in terms of how do we go about doing that, well, think from the beginning. What is the step you need to do? Well, in order to find k, you need to find h. All right, so how do we find h? Well, in order to find h, you need to find your intercepts. So there we go. Step 1, find zeros. Step 2 is use your formula. H is the r plus s over 2. Another way you can think of this formula is h equals x1 being the first intercept, plus x2 being the second intercept, divided by 2. They mean the same thing, okay? And then after that, you're going to evaluate your function at that h value, because that is going to give you your k value. Now you need to determine if it is a max or a min. So in order to determine if this k represents a max or a min, you have to look at the a, if it is whether or not it is positive. So is a positive or a negative. We'll determine what it is, maximum or minimum. So let's look at part A. So we can right off the bat notice that we have a positive 1 right in front, or just simply a positive a. So we know in this problem, a is positive. So our graph would look something like this, generally, meaning that it will open up. And when we go through our steps here, we are eventually going to find a minimum, okay? But let's go through our steps. First thing we need to do is we need to find our zeros. So step 1, find the zeros. Well, the zeros happen, and this is already put into factored form, by taking your factors and setting them to 0. So what I mean is take this 2x plus 3 and set that one to 0, and take x minus 4 and set that one to 0. Because you'll find your two values of x that would make the function 0. So rearranging this problem, bring the 3 over. So I'm just going to close the door for my dog. So bring the 3 over, and you're left with 2x minus 3. Bring the 2 over, and you get x is minus 3 over 2. That is one of your zeros. Okay? Do the other one. Well, in this case, it's much simpler. Bring the 4 over, you get x equals 4. There is your other 0. But again, go back. What is the big picture? What are we trying to do? Well, we need those zeros to then calculate the h value. So step 2, we're going to calculate what our h is. So h is equal to, and I'll use the x formula, just as more simpler. So if this is x1 and if this is x2 right here, well, really it's just taking x1 plus x2 dividing it by 2. So we get h equals minus 3 over 2 plus 4 divided by 2. All right, and just take your calculator, plug that in. All right, I'm not so worried about working with fractions now, okay? We don't need our answer in exact, so you take negative 3 divided by 2, add 4 to that, and then divide that by 2. And you would get 1.25, okay? So you have h equals 1.25. So what did you just find? Well, you have a vertex, and at that vertex, there is a x-coordinate of 1.25 and a y value of k, which we don't know yet. That's our goal. I should make this smaller, just so we have room. All right, well, step 3 is evaluating the function at that h value. So if we have our function f of x equals 2x plus 3, x minus 4, we are evaluating our function at that h value to find the k. We want the value when the x-coordinate is this. What is the y-coordinate? So when the x is 1.25, what is the y value? So that means 2 times 1.25 plus 3, 1.25 minus 4. So let's evaluate this. So this first bracket, 2 times 1.25 is 2.5 plus 3. This would become 5.5. And again, just use your calculator. And then this one right here, minus 1.25 minus 4. I'm going to do it on my calculator. Minus 2.75. My mental math isn't great right now. And then take those and multiply them. So negative 2.75 times 5.5. Oh, sorry, I did addition there. So 5.5 times negative 2.75. You'll get negative 15. Sorry, that's a 5. Negative 15, 1, 2, 5. All right, and we can just round that off. So roughly that's negative 15.1. We went to 2 decimals on the other, so we'll go 3. So what was the question asking? Determine the minimum or maximum value. So this is the value right here, right? Because there is our vertex, that is the y coordinate of our vertex, that is negative 15.13. And what that negative 15.3, as we mentioned above, it is a minimum because the a was positive. So therefore, a minimum at negative 15.13. So we'll do the same thing for over here. Go through your steps. So first step is we need to find our zeros. But the only problem here is this is given to us in standard form, not factored form. So we're just going to have an extra step. So if I used to add another step is we need to factor it first, because we have to factor to find our zeros. So looking at this, and again, hopefully this comes with good practice, you would see that you have to use decomposition to solve this. So if I use decomposition, that means I'm going to take my first and my last. And you know what? Actually, before I even do that, I'm going to factor out my GCF. I'm going to get rid of this negative right here, okay? Because this is going to make things much harder. So if I factor out that GCF, that negative in front, that just flips the signs of everything. So 3x squared plus 5x minus 12 now. Okay, now let's go from here, this step. Let me just move it down a bit so we have room. So take 3 and negative 12, you're going to get minus 36. So two numbers that multiply to give you minus 36. And those same two numbers need to add up to give you 5. So go through and think about what are your multiples of 36. And remember, because it is negative here, one of these will have to be positive and one of them will have to be negative. So doing that, and because this is also positive 5 here, you know the bigger number of the two is going to have to be the positive. So your option would then be 9 and 4. 9 plus minus 4. So you decompose the middle term, and again, you factored out that negative in the beginning. So 3x squared, and this becomes now plus 9x minus 4x minus 12. Do your grouping, and factor out your GCF from both bracket. So in the first one, in the first bracket, I can pull out a 3x. That would be my GCF there. So pulling out a 3x, this 3x, I'd be left with x plus 3. And if I pull a GCF out of the second bracket, that would be in this case minus 4. I'd be left with x plus 3. And again, from the review of doing all those decompositions, we know we've done it correctly because we have this bracket and this bracket being the same. So your final answer is you have one bracket being the common one, so the x plus 3, and your other bracket being the one on the outside, the 3x and the minus 4. And there are your zeros or your factors. So again, go back to what was the point of doing this? Big picture, you're solving for the min or the max, so we had to find our zeros first. So finding our zeros, we now take this factor, this x plus 3, set it to 0, and you would find 1 0 to be at minus 3 after you rearrange it. Do the same over here. Take 3x minus 4, set that to 0. And again, do your order of operations. So bring the 4 over first and then divide by 3. You would get x equals 4/3, or roughly 1.33. Okay, so now we're using our calculator because we're not going to have nice numbers, and we're going to calculate our h. So this was step 1, finding the zeros. Step 2, h is equal to minus 3 plus, and I'm going to put it as a decimal form right here. Okay, so I'm saying you're going to need your calculator. So minus 3 plus 1.33, all divided by 2. So you'll get an h value. H is equal to, so negative 3 plus 1.33, divide that by 2, and you'll get negative 0.835. So 8/4. We'll round up. Okay, we found the h. The last step is evaluate the function at that h value. So in this case, we have g of x equals, and it doesn't matter if you use factored form or standard form, they'll give you the same answer because they're the same quadratic. So we have minus 3x squared minus 5x plus 12. So I'm evaluating this g when h is minus 0.84. So you'll get minus 3, negative 0.84 squared minus 5, negative 0.84 plus 12. So use your calculator. So let's simplify this right here. So negative 0.84, square that, times that by 3. So roughly 2.11 or 12. And then you'll do negative 5 times negative 0.84. So plus 4.2 plus 12. All right, so 2.12 plus 12, you get 18.32. So that right there is your k value. And does that k value represent a min or a max? Well, we need to go up and look. What is the a value? Well, here, the a is negative. So it means we are opening down. So therefore we have a max at 18.32. Okay, last problem. So example 3, express the following equation in standard form, then determine the y-intercept, the direction of opening, and whether the optimal value be a maximum or minimum value. So let's get this into standard form. How do we get this in standard form? Well, we need to FOIL, expand out. So let's ignore this minus 2 first. Let's deal with the expansion. The reason I want to ignore that minus 2 first, I want to keep the numbers small, okay? It wouldn't have mattered if you put the minus 2 though in first. So foiling out, we have minus 2, we didn't do anything there, but we take again the 3 times the x, so you'll get 3x squared, 3x times the minus 4 there, so minus 12x, plus 1 times that x, plus x, and then plus 1 times that negative 4, minus 4. So that was foiling. Now we keep the minus 2 in front and collect like terms. So you'll get 3x squared minus 11x minus 4. Okay? Lastly, put that negative 2 into all terms. Remember, the negative 2 multiplies that 3x. So you'll get minus 6x squared, but it also multiplies that all terms, okay? So plus 22x, and then the last term in the back right there. And then you get plus 8. So there is standard form, okay? So remember, you FOIL out to go from factored to standard. So determine the y-intercept. The y-intercept. Well, remember from the note right above, the y-intercept is just simply looking at the value we see on the back here. So in this case, we have a y-intercept at the coordinate 0, 8. The direction of the opening, all right, well, the direction of the opening is determined by our a value. So look over here. Here we have an a value of negative 6. So the direction of opening, the DOO, direction of opening, is down because a is negative. A is negative. And whether the optimal value be a maximum or minimum, well, if we're opening down, that means our parabola looks like this. So the optimal value, right? Remember, this will have a h and a k. This is the optimal value. The optimal value is a max. We don't actually have to calculate k because it's not asking for it. It's just whether it would be a max or a min. So in this case, it'd be a max because it's opening down. Okay, if you have any questions, like always, start a question example and we can sit through and run through it in class, all right? Otherwise, here is the practice. Bye for now.